In the beginning there is only darkness. Not the ordinary darkness you see when you turn off a light, but a cosmic vastness so deep and silent that it feels alive. Imagine drifting upward from the blue cradle of Earth, moving past the thin veil of atmosphere, beyond the satellites that circle like mechanical fireflies, and into the cold, empty night. As the planet shrinks beneath you, the familiar dissolves and a strange truth unfolds. Everything you know, everything you love, everything humanity has ever created, exists inside a fragile bubble suspended in an ocean of black space. The solar system looks peaceful from a distance, planets orbiting like dancers, sunlight spilling across empty skies, but that serenity is a lie told by distance. The deeper you ascend, the more the scene begins to change. The light fades. Space becomes ink. Silence turns overwhelming. You begin to feel a strange tension, as if the universe is watching, waiting, withholding secrets that lie just beyond the reach of human understanding. As you drift farther, something unexpected happens. An invisible line reveals itself. Not visibly, not with light or color, but as a sensation, a shift, a boundary that marks the edge of everything familiar. It is the cosmic curtain, an unseen veil separating the world we can observe from the worlds we can only imagine. Beneath you lies the solar system, delicate and bright like a lantern in dark water. Above you stretches a realm of immense uncertainty, populated by forces and structures beyond the grasp of our senses. There is an ancient loneliness to this place. Space is vast beyond comprehension, yet here, near the edges of our own system, the loneliness feels thicker, heavier. You can sense the presence of the sun, a distant star glowing like a fading ember behind a curtain of dust and cosmic wind. Its warmth grows weaker. Its authority fades. Even light, the fastest thing in existence, seems hesitant as it moves outward, swallowed by a darkness that becomes more absolute with each passing mile. The planets look different now. Jupiter resembles a swirling storm painted on glass. Saturn's rings glow faintly like frozen ripples in time. Beyond them, the outer regions dissolve into hazy shadows. You feel as if you're standing in the wings of a cosmic stage, watching the familiar universe perform under a spotlight while something huge and unknowable waits silently in the dark just beyond the set. With each moment, your perspective warps. Scale becomes meaningless. Distance stretches into something your mind can barely hold. The solar system is no longer a comforting diagram from a school textbook. It is a fragile island surrounded by a sea of invisible forces, ancient storms, and cosmic predators. The farther you rise, the more the illusion of safety crumbles. A strange awareness settles in. The solar system is not the center of anything. It is not protected, not anchored, not surrounded by comforting barriers. It is drifting, quietly, slowly, vulnerably, through a galaxy filled with radiation, debris, magnetic fields, and gravitational currents that bend the fabric of space like waves in an unseen ocean. Yet the real mystery lies not in what you can see but in what you cannot. Above the solar system there are structures with no color, no light, no shape, only influence. Invisible currents that push against the heliosphere. Dark matter halos that cradle the entire system like a ghostly hand. Interstellar winds that whisper the stories of dead stars. They are ancient, powerful, and utterly indifferent to human existence. And beneath the solar system, in the regions we rarely think about, lie forgotten realms, dusty corridors, rogue objects drifting silently, and gravitational anomalies we do not yet understand. We picture the solar system as a flat disk, but it is not. It is a three-dimensional labyrinth of paths, orbits, loops, and unseen visitors entering from directions we never expect. Above and below are merely human words meant to simplify a universe that refuses to be simple. As you hover at the edge of this cosmic threshold, suspended between the known and the unfathomable, a haunting realization emerges. Everything we have ever mapped, measured, or imagined represents only a tiny sliver of what is truly out there. The universe hides its vast architecture behind layers of darkness, distance, and silence. It reveals just enough for us to ask questions but never enough to feel certain in our answers. You can sense that beyond this invisible curtain lies territory untouched by human eyes. Space that has never been lit by the sun, regions where the rules of the solar system crumble and new ones take shape. Domains filled with objects older than the sun itself, drifting across cosmic highways we have never traced. The space above and beneath our system is not empty, it is brimming with secrets waiting to be discovered. And as you float there, staring into the abyss, one final thought strikes with chilling clarity. If the solar system is a tiny bubble in an endless ocean, then something must exist beyond the water's surface. Something must press against the bubble's shell. Something must exist in the darkness that surrounds us, shaping us, watching us, perhaps even approaching us unseen. The curtain has been lifted just enough to reveal a hint of truth, but not enough to soothe the growing sense of awe and fear. You are left with a single echoing question. If this is only the doorway, what lies beyond it, and why has it remained hidden for so long? From a distance, the solar system appears simple, planets orbiting in neat, predictable paths, as if they were beads strung along invisible threads. But those threads are not imaginary. They are real, powerful, and woven through space like an unseen architecture that holds everything in place. When scientists map the solar system, they do not just plot planets and moons. They attempt to decipher the hidden structure that shapes their every move. It is a structure you cannot touch, cannot see, and yet it binds every world from the scorching surface of Mercury to the icy fringes of the Kuiper Belt. This invisible architecture is the very skeleton of our cosmic home. Imagine peeling away the planets, the asteroids, the comets, leaving behind only the gravitational fields, magnetic currents, and invisible lines of force that dictate their motion. You would discover a three-dimensional web stretching tens of billions of miles, sculpted by the sun's mass and carved by the gravitational pull of every orbiting object. It is like examining the backstage framework of a vast cosmic machine. The machinery is silent, but its influence is absolute. Gravity is the master architect here. It shapes the solar system the way wind shapes sand dunes. Slowly, relentlessly, and with patterns that reveal hidden stories. Every orbit is a footprint left behind by a gravitational conversation between the sun and its planets. Earth does not simply travel around the sun. It is pulled, tugged, balanced, and guided. Jupiter's immense mass bends space so dramatically that entire regions of the solar system dance to its rhythm. Even tiny asteroids, no larger than mountains, create their own minuscule distortions in the gravitational fabric, as if each piece of matter contributes to a symphony too complex for the human mind to fully grasp. Viewed from high above the solar system's plane, this architecture becomes even stranger. The orbits form spiraling paths rather than perfect circles, because the sun itself is not stationary. It is hurtling around the Milky Way at 500,000 miles per hour. This motion twists the orbits into elongated curves, like ribbons caught in a cosmic wind. The architecture is not static. It is alive, moving, breathing, constantly shifting. The solar system is not a stable diagram but a dynamic tapestry with threads woven through both space and time. Yet gravity is only one part of the structure. There are forces even more mysterious shaping the space between planets. Imagine magnetic fields stretching out like ghostly auroras, curving, twisting, and looping through millions of miles. The sun's magnetic field is so immense that it spirals outward, dragged by the solar wind, forming a shape scientists call the Parker spiral. It looks like a spinning, invisible whirlpool that wraps the entire solar system in its coils. These magnetic spirals can deflect particles, guide charged atoms, and sculpt the boundaries of the solar system itself. They create corridors through which solar storms travel, carving invisible highways of energy through interplanetary space. Sometimes these highways intersect Earth, unleashing breathtaking auroras. Other times they bypass our world entirely, leaving Earth undisturbed. It all depends on the architecture, on the precise twists and turns of fields we cannot see. If you could dive deeper into that structure, into the place where gravity and magnetism intersect, you would find something even more intricate: resonance patterns. These are the solar system's secret harmonies, mathematical rhythms where planets and moons align into repeating cycles. Jupiter and Saturn, for instance, fall into alignment every 20 years, creating a gravitational echo that reverberates through the solar system. Neptune's orbit resonates with Pluto's in a careful dance that prevents the two worlds from ever colliding, despite their crossing paths. These resonances are like the tension strings of a cosmic instrument. Pluck one string, disturb one orbit, and it can send vibrations cascading through the entire system. When a massive object enters the outer solar system, even from millions of miles away, these delicate harmonies shift. Some scientists believe this is why certain anomalies in the orbits of distant objects exist. Something large, unseen, may be pulling at the outer strings of the solar system's cosmic harp. The architecture becomes stranger still when we examine the dark voids between planets. These empty spaces are not truly empty. They are filled with streams of dust, drifting particles, and faint gravitational gradients that form channels, gateways through which comets and asteroids naturally flow. These gravitational corridors are like underwater currents guiding objects through invisible paths. A comet falling toward the sun does not take a random route. It slips into one of these hidden channels, drawn along a road that was shaped billions of years ago. Deep within this architecture, near the inner solar system, exists a zone known as the orbital sweet spot, a region shaped by the sun's warmth and the balance of gravitational forces. Here, rocky planets form, water can remain liquid, and life has the potential to emerge. It is not an accident that Earth orbits where it does. It is a consequence of the delicate, ancient structure that underlies everything. A structure so precise that even a slight shift in Earth's orbit would render it frozen or scorched. As you explore this invisible architecture, a realization begins to take shape. The solar system is held together not by chance, but by a delicate balance of forces interacting across billions of miles. It is a celestial machine whose gears are made of planets, whose pistons are gravitational waves, whose outer frame is shaped by magnetic fields and the sun's immense influence. The architecture is not just a structure, it is a blueprint for cosmic order. And yet, for all its beauty and symmetry, there is something unsettling about it. The architecture is incomplete. It has anomalies, orbital paths that don't align perfectly, objects that drift in unexpected ways, regions where no one knows what force is truly in control. These imperfections suggest that unseen influences are at work, forces that lie beyond current scientific knowledge. Perhaps dark matter crossing the solar system. Perhaps long-forgotten remnants of ancient cosmic collisions. Perhaps something even more mysterious lurking in the outer dark. The deeper you look, the more the architecture feels like a puzzle with missing pieces. A structure built by physics but whispered by something larger, something invisible, ancient, and omnipresent. The solar system's architecture is not just a map of orbits. It is a message written in gravity itself. A message humanity has only begun to decode. Before humanity ever saw the solar system from space, before telescopes revealed the icy edges of interplanetary darkness, the sun was simply a warm, familiar presence. A golden disk rising and falling each day. But this ordinary star holds a power far beyond light and heat. It breathes. It pulses. It expands and contracts like a colossal, living engine. And with every exhale, it releases a storm of charged particles, billions of tons of electrified solar wind, that blasts outward in all directions, forming a colossal bubble around our entire system. This bubble is the heliosphere, a cosmic force field stretching tens of billions of miles. It is the first and most powerful guardian of the worlds circling the sun. To understand its scale, imagine traveling far beyond Neptune, into the frozen silence of the outer dark. The planets fade behind you. Light weakens. Temperature plunges. And then, at some immeasurable distance, you reach a boundary where the solar wind begins to falter. Here, the sun's breath, after traveling for more than a century at unimaginable speed, meets the opposing wind of interstellar space. It is a collision of titanic forces, a battle between two invisible oceans. At this border, called the termination shock, the solar wind suddenly slows from supersonic to subsonic. It is a cosmic traffic jam, where waves of particles compress into a glowing, turbulent wall of distorted plasma. Though invisible to human eyes, this region behaves like a roaring waterfall crashing against stone, creating eddies, distortions, and shock waves that ripple through the dark. Beyond this lies the heliosheath, a chaotic, storm-tossed region where the solar wind is battered backward, twisted into spirals, and compressed into unpredictable patterns. It is a realm of turbulence and confusion, where solar storms lose their coherence and interstellar particles seep inward like cold fog. Voyager 1 and Voyager 2, the most distant human-made objects, entered this region decades ago. Their instruments recorded strange signals, eerie fluctuations, and particle densities no one had expected. The spacecraft were traveling through the solar system's outer heartbeat, a pulsing barrier that marks the limit of the sun's influence. But the true boundary lies even farther out, the heliopause. This is the frontier where the solar wind finally surrenders, unable to push any farther into the interstellar medium. It is the cosmic edge of home, the point where the sun's protective shield gives way to the vast unknown. Crossing it is like stepping from the warm shallows of a beach into the icy depths of an endless ocean. Inside the heliosphere, we exist in relative safety. The sun's magnetic field deflects high-energy cosmic rays, shielding planets from lethal radiation. Without this invisible fortress, life on Earth might never have emerged. The heliosphere is our cradle, our dome, our cosmic womb. Yet few people realize how fragile it truly is. This bubble is not uniform. It shrinks and expands with the sun's magnetic cycle. It shifts depending on the density of the interstellar material we drift through. At times, it becomes thinner, weaker, more permeable. During intense solar storms, the sun strengthens it. During quiet cycles, it weakens. And sometimes, during extreme cosmic events, it ripples and warps like fabric caught in a storm. Imagine floating near the outer edge of the heliosphere, looking inward. The sun is a tiny, distant star, its light weakened, its magnetic influence stretched thin. Around you, the charged particles of the solar wind swirl like dust in a faint golden haze. But beyond this haze lies a very different environment. Absolute darkness filled with particles from ancient supernovae, radiation that has crossed the galaxy for millions of years, and interstellar clouds that drift like massive shadows. It is here, at this fragile frontier, that the true danger lies. For every second of every day, cosmic rays slam into the heliosphere like invisible bullets. Some are deflected. Some are slowed. But some penetrate deeper, slipping through cracks in the sun's protective web. When the sun weakens, more rays enter. When the sun grows angry, fewer do. This balance has shaped Earth's climate, influenced extinction events, and perhaps even guided the evolution of life itself. Yet the heliosphere is not simply a shield, it is a ship. The entire solar system is embedded within it as it sails through the galaxy. It is pushed, compressed, and distorted by interstellar winds. It bends when we pass near cosmic clouds. It trembles when shock waves from distant supernovae sweep past. It is a bubble in motion, reacting to forces far beyond human sight. Some scientists describe the heliosphere not as a sphere, but as a teardrop or comet shape, trailing behind the sun as it moves through the Milky Way. Others argue it is shaped more like a croissant, with folded magnetic lobes. The truth may be stranger still. Voyager data suggests the heliosphere may not have a tail at all, a revelation that challenges decades of assumptions. It may be shaped by magnetic pressure rather than pure solar wind. It may twist into forms we cannot yet imagine. This uncertainty makes the heliosphere one of the most mysterious structures known to science. It is enormous, ancient, vital, and yet almost entirely invisible. We detect it only through particle counts, magnetic fluctuations, and faint radio emissions. It is a presence we feel more than see, a force that exists between the light of the sun and the darkness beyond. Inside this vast bubble, Earth circles in a delicate arc. If the heliosphere were to weaken drastically, cosmic radiation would surge. Astronauts venturing beyond Earth's magnetosphere would be at extreme risk. Technology could falter. Biological systems could be strained. Climate patterns might shift. The heliosphere protects us, shapes our environment, and silently dictates the limits of human exploration. But the most unsettling truth is this: we do not know how long this bubble has existed in its current form, nor how long it will remain. As the solar system drifts through the galaxy, it encounters different regions of interstellar space. Some are denser. Some are emptier. Some are filled with magnetic turbulence or heavy ion streams. Eventually, the solar system may enter a cloud so dense that the heliosphere could shrink dramatically, exposing Earth to levels of cosmic radiation far higher than today. When that happens, the planets may experience environmental changes unlike anything humanity has known. Standing at the edge of the heliopause feels like standing at the edge of a cosmic cliff. Behind you is the familiar domain of the sun, ahead lies interstellar night, vast, cold, ancient, and unknown. The protective bubble surrounding everything you've ever known begins to fade like a dim halo against the abyss. And you cannot help but wonder, what lies beyond this fragile shield? What forces watch from the darkness outside? What secrets drift just beyond the sun's breath? The heliosphere is our fortress, but beyond its edge the universe waits. Beyond the sun's protective bubble, past the trembling edge of the heliopause, lies a realm that almost defies imagination. It is the interstellar medium, a vast ancient ocean that stretches between the stars. It is not empty space, not a void without character, but a silent sea filled with drifting particles, violent radiation, and the remnants of long-dead suns. Here light itself seems to struggle. Darkness thickens. The familiar touch of the sun fades until it feels like nothing more than a distant memory. Imagine leaving the heliosphere behind, watching it recede like a glowing bubble in the endless dark. For the first time, you are exposed to the true environment of the galaxy. The silence here is deeper, heavier, almost suffocating. Dust grains float like ash from forgotten cosmic fires. Atoms wander alone, separated by distances so vast that each one feels like a lonely traveler crossing a desert of eternity. This ocean is thin, far thinner than even the emptiest vacuum on Earth, but it is relentless. Over millions and billions of miles, its faint particles build up into a force capable of shaping entire systems. Every grain of dust, every wandering ion, every high-energy particle drifting here carries a story. Some come from supernova explosions, the violent deaths of stars that once burned brighter than entire galaxies. Some come from ancient molecular clouds that have existed since before the sun was born. Others are fragments of planets, pulverized long ago in collisions too violent for human imagination. Together, these particles form the invisible fog that fills the Milky Way. But this fog is not uniform. It shifts, thickens, thins, and swirls, creating vast rivers and currents that only stars and solar winds can feel. The solar system, drifting through the galaxy, moves through these currents like a boat moving from calm waters into stormy seas. Sometimes it passes through regions so empty they border on true void. Other times it brushes against dense cosmic clouds where radiation thickens and the heliosphere shrinks like a collapsing lung. The temperature here is near absolute zero. Heat evaporates into nothingness. Matter slows. Molecules struggle to hold themselves together. And yet, despite this profound cold, violent energy lurks everywhere. Cosmic rays, charged particles moving at nearly the speed of light, stab through the darkness like microscopic bullets. These rays can slice through DNA, penetrate spacecraft, and leave streaks in detectors like ghostly signatures of unseen enemies. They come from all directions, from sources far beyond comprehension. Exploding stars, black hole jets, and turbulent regions of the galaxy where magnetic fields twist like cosmic hurricanes. In this environment, even time feels different. Without the sun's warmth, without familiar orbital rhythms, seconds stretch into a kind of slow, suspended drift. Distances lose meaning. Light from distant stars passes through the interstellar medium and scatters, bends, dims. The dust clouds act like cosmic stained glass, filtering and shaping starlight into subtle smears of red and blue. Every color you see through these clouds is altered, distorted, tinted by particles that have been floating here since before Earth existed. As you drift deeper into the interstellar medium, you begin to sense its vastness. The nearest star system, Alpha Centauri, is more than 4 light-years away, an impossible distance of emptiness and drifting debris. Between the stars, enormous structures stretch across space like mountains of dust and gas. Some are small, no larger than planets. Others are massive nebulae so big that they could swallow the entire solar system without leaving a trace. If you could fly through one of these nebulae, you would enter a world of swirling colors and ghostly formations. But out here, between such nebulae, the medium is thin, faint, almost weightless. It is a place of transitions, where remnants of dying stars drift toward the birthplaces of new ones. Hydrogen atoms, the simplest and most ancient form of matter, float endlessly, waiting for gravity to gather them into clouds dense enough to collapse into new suns. This ocean is the birthplace of worlds and the graveyard of old ones. Yet, despite its beauty and quiet mystery, it is hostile beyond measure. Human beings, unshielded, would not survive even moments here. Spacecraft would be slowly eroded by microscopic particles moving at immense speeds. Electronics would be crippled by radiation. Magnetic storms would tear at sensors like cosmic winds trying to peel metal apart. And still, the interstellar medium is not an enemy, it is simply indifferent. It does not care about life, stars, or planets. It is the silent stage upon which the galaxy performs its ancient cycles. Stars are born here, live here, and die here. Their ashes drift through this space. Their energy pulses across it. Their remnants collide and merge, forming the next generation of cosmic structures. The medium is the Milky Way's bloodstream, circulating matter and energy from one region to another. When you look back toward the solar system from this distance, it appears impossibly small, just a tiny pocket of warmth glowing inside a vast ocean of cold. The heliosphere surrounds it like a fragile bubble shimmering in the dark. Inside that bubble, life thrives. Outside it, ancient dust drifts endlessly, waiting for gravity or chance to give it purpose. One unsettling thought lingers: the interstellar medium is not static. It is dynamic, shifting over time, drawing closer to and receding from the solar system as we move through the galaxy. In the future, the sun may drift into a denser region of this medium. If that happens, the heliosphere could shrink dramatically, allowing far more cosmic radiation to reach Earth. Climate patterns could shift. Planetary atmospheres could thin. Life could face challenges unseen for millions of years. The interstellar medium does not attack, but it waits. It waits for stars to move, for clouds to collapse, for cosmic winds to change direction. And everything, every planet, every comet, every star, must eventually pass through it. Out here, you realize that the space between stars is not emptiness. It is history. It is memory. It is the drifting remains of everything that has ever lived and died in the galaxy. It is the raw material of futures yet unformed. And as you hover in this ancient, silent sea, one feeling becomes impossible to ignore. The solar system is not alone. It is surrounded, shaped, and influenced by forces that stretch far beyond the faint glow of the sun. And the journey into this dark ocean has only just begun. Far beyond the bright sweep of the planets, past the lonely orbits of Neptune and the scattered icy wanderers of the Kuiper Belt, lies a region so vast and so mysterious that humanity has never seen it, not directly, not even once. It is the Oort cloud, a frozen halo surrounding the solar system like a distant, ghostly shell. It stretches almost a full light year in every direction, an immense sphere of ancient ice and cosmic debris. To imagine its scale, picture the sun shrinking to the size of a grain of sand. The Oort cloud would then be a sphere stretching several miles around it. That is how far its influence reaches. That is how enormous this invisible kingdom truly is. Yet despite its size, the Oort cloud is almost impossibly empty. Its objects, trillions of them, are separated by distances so immense that each icy body is like a lonely island in a black ocean. These fragments are relics from the dawn of creation, bits of frozen rock and primordial ice left over after the planets formed. They drift in the darkness, untouched, unchanged, waiting in silence for millions or even billions of years. If you could travel there, you would find yourself in a realm where ordinary concepts of distance, light, and time dissolve. The sun would appear no brighter than a distant star, a pale dot barely distinguishable from the background of the Milky Way. Heat would be non-existent. Silence would press against you from every direction. Here the universe feels both infinite and unbearably still. The bodies of the Oort cloud are ancient wanderers. Some were born near the sun but ejected outward by the gravitational pushes of giant planets. Others may be captured fragments from other star systems, stolen long ago when the sun was still young and drifting through its birth cluster. Some may have been formed by collisions that shattered early planetesimals, sending debris into deep space. Each piece carries a history older than Earth itself. These objects are icy archives containing the first materials that ever existed in the solar system. They hold water more ancient than Earth's oceans, frozen gases from the nebula that gave birth to the sun, and chemical fingerprints from a time before planets existed. If one of these icy fragments could be brought back to Earth untouched, it would be like opening a time capsule from 6 billion years ago. But the Oort cloud is not just a museum of the past. It is also a sleeping giant, a reservoir of potential destruction. Most long-period comets come from this distant region. These comets plunge into the solar system after eons of stillness, falling inward on paths shaped by invisible forces. A gentle nudge from a passing star. A ripple in the galactic tide. A gravitational whisper from the Milky Way itself. That is all it takes to set one of these frozen wanderers into motion. Imagine an object the size of a mountain, wrapped in ices of carbon dioxide, methane, ammonia, and water, drifting peacefully at the edge of the solar system. For millions of years, it remains untouched. Then something changes. Perhaps a star passes within a light year, its gravity nudging the icy body ever so slightly. Perhaps the solar system moves deeper into the galactic plane, and the gravitational tides of the Milky Way shift. The comet begins to drift inward, slowly at first, then faster and faster, until it plunges toward the inner planets in a fiery descent. When it approaches the sun, it erupts into a blazing coma and tail, its ancient materials boiled into vapor by sunlight for the first time in cosmic history. These comets, though beautiful, are among the most dangerous objects in existence. They move at tens of thousands of miles per hour. They arrive from unpredictable directions. Their orbits can last millions of years, appearing suddenly from the darkness like cosmic arrows fired by an unseen hand. Many mass extinction events on Earth are believed to have been triggered by impacts or near passes from such objects. Though rare when they strike, their effects reshape worlds. The Oort cloud is therefore both cradle and predator. It nurtures the ingredients of life while also containing the seeds of destruction. It is a cosmic paradox, a frozen halo of creation and danger, innocence and threat. If you were to journey deeper into the Oort cloud, you would encounter a strange, shifting environment shaped by forces from inside and outside the solar system. The sun's gravity still holds sway here, but only barely. Beyond a certain point, the gravitational pull of other stars becomes comparable. Here, the solar system ends not with a sharp line but with a vast region of uncertainty, a blurry border where objects may belong to the sun one moment and drift toward another star the next. This region is also influenced by the galactic tide, a subtle gravitational pull exerted by the mass of the Milky Way. It stretches the Oort cloud, distorting its shape over millions of years. Think of it as the slow, steady rise and fall of an ocean, but on a scale so vast that entire star systems ride its currents. Some scientists believe that every few tens of millions of years as the solar system moves through the galaxy, the Oort cloud becomes disturbed. More comets are dislodged. More wanderers fall inward. Some researchers even suggest this may be linked to cycles of mass extinctions on Earth. Perhaps it is coincidence. Perhaps not. The universe rarely reveals its intentions clearly. But the most haunting mystery of all is this: we cannot see the Oort cloud directly. Not even with our most powerful telescopes. Its objects are too small, too far, too cold. We only infer its existence from the behavior of long-period comets. We know it is there because something must send those comets toward us. But the Oort cloud remains a shadow, a theory supported by evidence but hidden from view. And in that shadow lie possibilities that stretch the imagination. Could unknown objects drift there? Planets, dwarf planets, or strange bodies unlike anything in the inner solar system? Could remnants of other solar systems be trapped in its depths? Could ancient interstellar visitors have been captured billions of years ago and now lie frozen in dark, distant orbits? If so, the Oort cloud may be more than a relic. It may be a cosmic archive of not just the solar system's history but the galaxy's. As you drift farther outward, the icy bodies fade from view. The sun's light diminishes to nothing. The planets are gone. Even the heliosphere is far behind you, no longer a visible boundary but a distant memory. The Oort cloud stretches farther still, into regions where starlight becomes thin and time feels suspended. Here, at the edge of everything, these icy wanderers float in patience. Some will remain here forever. Others will fall inward to burn briefly and beautifully in the sun's light. And some, perhaps, will leave the solar system entirely, drifting into interstellar space to become messengers between stars. The Oort cloud is the solar system's final frontier, a halo of frozen secrets encircling everything we know. It guards ancient stories we have not yet learned to read. And as you look into its endless expanse, one question echoes through the darkness: how many of its ghosts are waiting for their moment to awaken? In the vast quiet between the stars, there are travelers that do not belong to us. Objects that were born in distant systems, shaped by alien suns, and flung across the galaxy by forces we may never understand. These are the rogue wanderers, interstellar visitors that slip silently into the solar system without warning, without pattern, without allegiance to our familiar celestial order. They are cosmic strangers, intruders from places far beyond the reach of any spacecraft humanity has ever launched. The first time one of these visitors was confirmed, it changed our understanding of the solar system forever. Oumuamua arrived in 2017 like a whisper from the dark. It appeared suddenly, moving too quickly, cutting through the inner solar system on a trajectory no comet or asteroid had ever taken. It was long, thin, tumbling end over end like a shard of something broken loose from a distant world. It reflected sunlight in strange, uneven ways. It accelerated slightly without any visible release of gas or dust. For a moment, humanity stared at a single, silent object and wondered if it was natural, or something else entirely. And before the question could be answered, it was already gone, racing back toward interstellar space. Not even 2 years later, Borisov arrived. Another interstellar traveler, this time behaving more like a comet, shedding gas and dust as it passed the sun. But even Borisov was different. Its chemical composition did not match anything found in our solar system. It carried within it the frozen ingredients of an alien world, materials shaped by the unknown environment of a foreign star. These two visitors revealed a truth long suspected but never proven. The galaxy is full of wandering debris, and the solar system is not isolated. It is exposed, vulnerable, open to whatever drifts within reach. And these visitors may not be rare. They may be far more common than we realize. The reason we rarely detect them is simple: they are dark, fast, and small. Most would slip past Earth completely unnoticed, like shadows gliding through the cosmic deep. Only when their paths cross the faint glow of sunlight do they reveal themselves, and even then only briefly. Imagine standing at the edge of the solar system, looking outward into the endless night. Every so often, something moves against the background of stars. Something faint, cold, and ancient. A fragment of a shattered planet. A chunk of ice blasted from a forming solar system. A sliver of material ejected by a star that once burned bright and long ago collapsed into silence. These wanderers carry secrets older than the sun. Some may have drifted through interstellar space for hundreds of millions of years, untouched, their surfaces polished by cosmic rays into dark, glossy stone. If you could follow one of these objects back to its source, it would lead you across unimaginable distances, through dark nebulae, through star-forming regions where newborn suns ignite, through ancient clusters where stars flicker like dying embers. Each object is a messenger, a relic from another place and another time. But these visitors are not just harmless curiosities. Their presence introduces new dangers, unpredictable trajectories, unknown compositions, and unimaginable speeds. Interstellar objects move faster than almost anything bound to the sun. A collision between one of these wanderers and a planet would unleash catastrophic energy. Even a relatively small fragment, traveling at interstellar velocity, could carve a continent-sized wound into a world. Yet for every threat they bring, they also offer possibility. These objects carry chemistry shaped by foreign conditions. Inside them may lie molecules that never formed within the solar system, compounds that hint at alien oceans, exotic atmospheres, or unknown forms of geology. They may hold clues about the diversity of planets across the galaxy, clues drifting across interstellar space, waiting to be discovered. Some scientists believe that life's building blocks could be transferred between star systems on such objects. The idea of panspermia, life spreading through space on drifting rocks or icy fragments, gains new weight when interstellar visitors are proven real. If life once arose on a distant world, microscopic traces of it might survive frozen inside an object like Borisov, protected for eons by ice and rock. Perhaps the galaxy is not as disconnected as it seems. Perhaps every star system is linked by a slow, silent exchange of material. Perhaps the seeds of life drift among the stars like pollen riding the wind. And still, many questions remain unanswered. How many interstellar visitors pass through our system each year without detection? How large do they get? Could entire rogue planets, floating worlds unbound to any star, drift into the solar system someday? Could dark, frozen exoplanetary debris be orbiting our sun right now, hidden among the countless objects of the outer dark? The most unsettling possibility is that some visitors may not be random at all. In a galaxy filled with billions of stars, civilizations, if they exist, might send probes, artifacts, or even automated explorers across interstellar distances. Not with engines, not with transmissions, but with patience, with time, with physics. A silent fragment, drifting between stars, could be a messenger, or a relic, or something placed intentionally long before humanity learned to look up. Oumuamua's strange behavior sparked debates that have not ended. Natural? Artificial? Something in between? The universe offers no explanations, only mysteries. As you drift back toward the sun, the thought lingers like a cold breeze. These wanderers do not announce themselves. They do not shine. They do not follow the rules of our system. They arrive from directions we cannot predict, carrying stories we cannot read, shaped by worlds we may never see. Rogue visitors will come again. Some we will detect. Many we will miss. But each one will pass through our system like a ghost, silent, fleeting, ancient. And for the briefest moment, the solar system will feel the touch of the unknown. And every time one appears, humanity will be reminded of a haunting truth. We are not alone in our cosmic journey. The galaxy is watching, drifting, crossing paths with us through these shadowed messengers. And we may never know what the next visitor brings. High above the familiar plane of the planets, beyond the faint, icy debris of the Kuiper Belt and the distant whispers of the Oort cloud, an unseen structure stretches through the solar system like a colossal, ghostly web. It does not glow. It does not cast shadows. Yet it shapes everything: the flow of charged particles, the movement of cosmic dust, the path of comets, and even the protective boundaries surrounding the sun. This is the galactic magnetic web, a vast, interwoven network of magnetic fields that ripple through the Milky Way like invisible rivers of power. Imagine drifting upward from the solar system, rising through the cold, dark expanse beyond Neptune's orbit. The planets shrink into a thin, glowing line. The sun dims behind veils of dust and distance. As you continue your ascent, something subtle begins to change, something you cannot see but can almost feel. The space around you seems to twist, as if faint currents are brushing past, pushing, tugging, guiding. These currents are the magnetic tendrils of the galaxy, stretching across thousands of light years, connecting star systems like threads in an enormous cosmic tapestry. The Milky Way is not just a collection of stars. It is a living engine of electromagnetic energy. Every star, every supernova, every swirling nebula contributes to its magnetic structure. But the heart of the galaxy does more than generate fields. It stretches them, bends them, and shapes them into a network that flows like blood through galactic arteries. The solar system, traveling through the Milky Way at stunning speeds, moves through these magnetic streams like a ship caught in shifting tides. If you could see these fields with your eyes, the galaxy would not appear as a simple spiral of stars. It would resemble a glowing net of twisted filaments and looping arcs. Some fields would stretch smoothly for thousands of light years, while others would curl into turbulent knots, churning violently like storm clouds. The solar system sits inside one small region of this vast magnetic web, but even this tiny corner of the galaxy is far more dynamic and powerful than it appears. Here, magnetic fields influence the flow of the solar wind, bending and twisting it into spirals as it reaches outward from the sun. At the edge of the heliosphere, these magnetic forces become more pronounced. They press against the sun's protective bubble, warping it, compressing it, sometimes stretching it into irregular shapes. Where the heliosphere weakens, these fields slip through more easily, carrying energetic particles that can penetrate deep into the solar system. Magnetic reconnection, a dramatic event where opposing magnetic fields snap, merge and release massive bursts of energy, occurs constantly along these boundaries. Each reconnection is like a cosmic lightning strike, unleashing sudden flows of charged particles that ripple through space like shockwaves. These waves can strengthen or weaken the heliosphere, depending on the direction of the galactic field. They can open temporary gaps, allowing interstellar radiation to spill inward. The solar system is not an isolated bubble. It is a drifting vessel, constantly impacted by galactic magnetic weather. Travel far enough upward, and you would find yourself moving through regions where the magnetic fields intensify. These regions twist space subtly, slowing or redirecting cosmic rays, altering their paths in ways that can redirect deadly radiation away from, or toward, the inner planets. Earth's atmosphere protects us from many cosmic horrors, but the planet relies heavily on the sun's magnetic shield and the intricate influence of the galactic magnetic environment. Without them, Earth would be bombarded endlessly by high-energy particles that could strip away the atmosphere and sterilize the surface. Out here, in these upper regions above the solar system, charged dust grains drift along magnetic lines like tiny metallic ships caught in invisible currents. Comets that pass through these regions are subtly redirected, their tails shaped by the magnetic environment they encounter. Even the orbits of distant objects, icy bodies far beyond the planets, can be influenced by the quiet, persistent pressure of these galactic magnetic forces. The magnetic web also carries the echoes of ancient cosmic events. Supernova explosions, for instance, leave behind shockwaves of magnetized plasma that expand outward for thousands of years. These shockwaves travel through the galaxy like ripples on water. Eventually, they reach regions such as the solar system, disturbing magnetic fields, altering the flow of interstellar particles, and sometimes compressing the heliosphere for centuries. These disturbances may leave chemical signatures on planets, influencing geological and biological histories in ways humanity has not yet fully understood. Deeper within the magnetic web lie structures that scientists call filaments, vast, rope-like channels stretching across interstellar space. These filaments are dense, twisted regions of magnetic energy that often guide matter into long, thin pathways. Inside them, dust gathers, gas accumulates, and stars sometimes begin to form. These filaments act like highways, directing the flow of matter through the galaxy. They may be responsible for the movements of some of the farthest comets in the Oort cloud, pulling them into positions where gravitational nudges can send them inward. But the magnetic web is not constant. It shifts, flexes, and evolves over time. As the solar system travels around the galaxy in its 230 million-year orbit, it encounters different regions of magnetic intensity. Sometimes it drifts through quiet areas, where fields are weak and turbulence is minimal. Other times it enters chaotic zones filled with energy, turbulence, and distortion. When this happens, the heliosphere may shrink or expand. Particle flows may increase or decrease. Climate patterns on Earth could shift subtly over thousands of years, influenced by changes in cosmic ray levels, changes tied directly to the galactic magnetic environment. The most enigmatic aspect of the magnetic web, however, is its interaction with dark matter. Though invisible and undetectable except through gravity, dark matter may influence the shape and motion of these magnetic streams. Some theories suggest dark matter clumps create distortions that twist galactic magnetic fields into new shapes. Others propose that the filaments guiding matter through the galaxy are partly anchored by dark matter structures. If true, then the magnetic web is not just a product of stars and plasma, but a reflection of the hidden architecture of dark matter itself. Imagine drifting farther upward, watching the solar system become a tiny spark in a massive magnetic ocean, its heliosphere just a shimmering bubble floating in a turbulent field of unseen power. The magnetic web stretches beyond sight, beyond imagination, influencing every particle, every planet, every beam of radiation that moves through its currents. It is a silent puppeteer, guiding the cosmic dance with threads woven from pure force. And as you drift through these invisible rivers, you cannot escape a haunting realization. The solar system is not simply moving through the galaxy, it is being shaped by it. Wrapped, pressed, and sculpted by lines of force older than the sun, carried along by currents that span thousands of light years. Surrounded by energies we barely understand. Above the solar system, the magnetic web waits, vast, ancient, and alive with cosmic storms. And its influence reaches far deeper than we. Far above the familiar orbits of the planets, beyond the drifting comets and the fading reach of the sun's magnetic breath, lies something far more mysterious than dust, radiation, or frozen debris. It is not made of atoms. It does not reflect light. It cannot be seen with telescopes, no matter how large or sensitive. And yet, its presence is undeniable. It shapes galaxies, bends starlight, sculpts cosmic structures, and envelopes the solar system in an invisible halo of silent influence. This unseen substance is dark matter, a ghostly, omnipresent medium woven throughout the universe like an ancient, formless shadow. To understand dark matter, imagine drifting upward through the solar system until the planets shrink beneath you. Jupiter becomes a pale marble, Saturn's rings dissolve into faint glimmers, and the sun dims into a distant ember. As you continue rising, the stars around you brighten, revealing the spiral arms of the Milky Way stretching like ethereal wings across the cosmic night. The galaxy appears graceful, balanced, serene. Yet what you see, every star, every nebula, every glowing filament, makes up only a tiny fraction of what actually exists. The true mass of the galaxy is hidden, like a giant sleeping beneath a thin layer of snow. This hidden giant is dark matter. Scientists discovered its presence not by seeing it, but by watching what it does. Stars orbiting the edges of galaxies move too quickly. They should be flung into intergalactic space by centrifugal force, yet they remain bound. Something invisible must be holding them in place, exerting gravity without emitting light. Something enormous. Something that outweighs ordinary matter by a factor of 5. Without this unseen mass, galaxies would unravel like spinning wheels without spokes. The solar system too drifts inside this dark matter halo. Though dark matter does not cluster like gas or dust, forming planets or stars, it permeates every corner of galactic space. There are no dark matter planets, no dark matter asteroids, no dark matter comets. Instead, imagine a vast, diffuse cloud of invisible mass passing effortlessly through everything, through the sun, through Earth, through your own body, without resistance. It is everywhere and nowhere, present but undetectable except through gravity. If you could see dark matter, the solar system would appear suspended within a faint, ghost-like sphere extending far beyond the Oort cloud. This sphere does not have sharp edges. It does not shimmer or pulse. It simply is, a gravitational sea holding the planets in a deeper cosmic embrace. As you drift through it, you would feel no wind, no pressure, no sensation at all. Dark matter does not interact with light or magnetism. It does not collide or clump. It does not freeze or evaporate. It passes through the solar system like a shadow drifting across a dream. And yet its influence is immense. As the sun moves through the galaxy, it drags its planets along behind it, carving a path through the dark matter halo. This path is not smooth. Some regions of dark matter may be denser, others thinner. When the solar system passes through subtle dark matter gradients, the orbits of distant objects may shift ever so slightly. These shifts are far too small for the human eye, but over millions of years they may influence the trajectories of comets, the structure of the Oort cloud, or even the stability of distant dwarf planets. Some theories suggest that dark matter may leave faint imprints on the movements of celestial bodies, especially objects far from the sun where gravity is weakest. Anomalies in the orbits of trans-Neptunian objects, odd tilts, unexpected clustering, may hint at the silent tug of dark matter streams. Perhaps Planet 9 is not a planet at all, but a dense pocket of dark matter exerting its own gravitational pull. Perhaps entire regions of the outer solar system are shaped by invisible tides we cannot yet measure. Dark matter also surrounds the Milky Way in enormous filaments stretching across intergalactic space. These filaments act like cosmic scaffolding, guiding the formation of galaxies and determining where stars can form. They create a vast, unseen skeleton of the universe, a colossal framework upon which everything luminous is built. If ordinary matter is the flesh of the cosmos, dark matter is its bone. As you drift through this silent halo, you might wonder how something so massive can remain forever unseen. Scientists have spent decades trying to detect it directly, using deep underground detectors, hoping for rare collisions between dark matter particles and ordinary atoms. So far, dark matter has remained silent, refusing to reveal its true nature. It might be made of exotic particles that barely interact. It might be a manifestation of physics not yet understood. It might be something stranger still, something that exists not entirely within the fabric of space but alongside it. Some theories propose that dark matter is a shadow of another universe, bleeding gravitational influence into our own. Others suggest it is a type of matter from higher dimensions, slipping through our three-dimensional world like a breeze through a net. These ideas may sound like science fiction, yet they arise from serious scientific efforts to explain a phenomenon too large to ignore and too subtle to grasp. Even more haunting is the idea that dark matter may affect time itself. Regions rich in dark matter may warp the flow of time slightly differently than empty regions. Space, time, gravity, and matter intertwine in ways far stranger than human intuition allows. From your vantage point high above the solar system, you sense the immensity of this hidden halo. It surrounds the planets like an invisible blanket, extending light years in every direction. It holds the sun in place within the galactic structure. It slows the drift of stars. It shapes the motion of entire spiral arms. And yet, if you reached out your hand, you would touch nothing. The solar system is small and fragile compared to this vast, unseen ocean. It is like a tiny boat floating inside a massive, invisible sphere whose boundaries and currents we cannot see. Dark matter shapes our destiny without our knowledge. It influences the sun's journey, the planet's paths, and the long-term evolution of the system. As you gaze into the dark, a chilling thought settles over you. The universe may be controlled not by the matter we see, but by the matter we cannot. The familiar cosmos, stars, planets, nebulae, is only a thin layer resting atop a deeper reality. And the more we learn, the more it becomes clear that the solar system is wrapped in mysteries far larger than anything we have yet imagined. Dark matter is not just around us. It surrounds us completely, silently shaping the fate of everything we call home. Beneath the familiar flat plane of the solar system, beneath the orbits we imagine as a clean, organized disk, there exists a realm almost never shown in textbooks or diagrams. We tend to picture the planets aligned neatly like beads on a wire, drifting in a two-dimensional sheet. But this vision is an illusion created by simplicity. In reality, the solar system is a three-dimensional labyrinth, full of strange angles, tilted worlds, wandering bodies, and gravitational distortions that stretch far above and far below the plane we think of as home. Slip beneath that plane, and you enter a hidden underworld, a cosmic basement filled with forgotten relics, unsolved mysteries, and the oldest clues to our origins. As you descend below the orbital sheet, the first sensation is disorientation. The sun's light, once comfortably familiar, begins to take on a different geometry. The planets you know, Mars, Jupiter, Saturn, no longer line up in a tidy arc. They drift overhead like glowing islands suspended in a sea of darkness. Their orbits form vast, looping tracks above you, reminding you that up and down are human constructs, meaningless in the vacuum of space. Here in the solar system's underworld, direction itself seems to unravel. The space below the plane is not empty. It is populated with small, dark objects, asteroids, dwarf planets, centaurs, and ghost-like fragments that drift in eccentric orbits. Many of these bodies have paths so steeply inclined that they never cross the planetary plane at all. Instead, they swing above and below it like pendulums in an endless cosmic rhythm. These objects are clues, cosmic breadcrumbs left behind by ancient forces. Take the centaurs, for example, icy rocky hybrids orbiting between Jupiter and Neptune. They are unstable, unpredictable, destined eventually to be ejected from the system or pulled inward to become comets. Their tilted orbits are evidence of past gravitational encounters, moments when giant planets deflected them, scattering them into strange, looping paths. By studying these trajectories, scientists can reconstruct the solar system's chaotic youth, a time when planets migrated, clashed, and reshaped everything around them. But the real mysteries lie even deeper. As you drift farther beneath the ecliptic, you begin to encounter objects whose orbits defy explanation. Some are small and faint, barely reflecting sunlight. Others are large enough to be considered dwarf planets, yet they move in patterns that cannot be traced to any known force. These bodies, including Sedna and other distant trans-Neptunian objects, have elongated orbits tilted far above and below the planetary plane. Their paths stretch so far into the outer dark that they seem to be guided by a hidden hand. What force placed them in such unusual orbits? What disturbed them so deeply that they no longer follow the familiar gravitational dance of the planets? Some researchers believe the answer lies in the early history of the solar system. Perhaps another star passed close to the Sun billions of years ago, scattering objects and tilting their orbits like debris tossed into swirling water. The idea is not far-fetched. The Sun was born in a cluster of stars, and close stellar encounters would have been common in that environment. A passing star could easily have tugged at the outer disk, reshaping the orbits of distant bodies and leaving them with inclinations that persist even now. Others suggest something even more dramatic: the influence of a massive, unseen world lurking far beyond Neptune. This hypothetical object, often called Planet 9, might have a tilted orbit of its own, pulling distant bodies into matching inclinations. If such a world exists, it would be a giant planet, perhaps 10 times the mass of Earth, orbiting hundreds of times farther from the Sun than Neptune. Its gravitational influence could explain the clustering of distant objects and the strange angle of their paths. But despite years of searching, no planet has yet been found. Still deeper still lie objects whose orbits are so anomalous that they may point to something more exotic. Some scientists have proposed the existence of a dark matter substructure, an invisible gravitational clump embedded within the solar system's outskirts. Such a clump, if real, could exert subtle tugs on distant bodies, pulling their orbits into tilted, elongated shapes. If the solar system is drifting through filaments of the galactic dark matter web, these structures might leave fingerprints beneath the ecliptic, ghostly gravitational signatures hidden within the motions of small, distant worlds. The underworld contains darker mysteries too: fragments from collisions between dwarf planets, icy shards shattered billions of years ago, drifting silently through frigid blackness. Some pieces show unusual compositions: exotic ices, complex organic molecules, materials formed in environments unlike those of the inner solar system. These fragments hint at lost worlds, ancient bodies that once existed in abundance but no longer remain intact. Their remnants circle beneath the ecliptic as silent witnesses to the solar system's violent past. As you move through this realm, the view becomes haunting. The major planets glow above like distant lanterns, while below you stretch countless invisible highways, orbital paths looping through space like forgotten roads. These orbits cross and diverge in strange angles, forming patterns no map has ever fully captured. The entire structure resembles the hidden foundation of a cathedral, the unseen supports beneath a grand cosmic architecture. Far beneath the ecliptic, gravitational forces behave differently. The pull of the Sun weakens. The influence of the galaxy grows. Here, the Milky Way itself begins to tug at the outer solar system, creating a subtle downward force, an effect known as the galactic tide. This tide slowly shifts the orbits of distant bodies, deforming paths and lifting or lowering them over tens of millions of years. In this deep underworld, the solar system is no longer governed only by the Sun. It is shaped by the gravity of the entire galaxy. In this dim region, comets begin their long journeys inward. Many long-period comets start their descent from orbits far beyond the ecliptic, falling toward the Sun like icy arrows fired from the darkness. As they approach, they bring with them materials untouched since the dawn of the solar system. The underworld is therefore not just a graveyard of old objects. It is a birthplace of future wonders, a region where icy bodies are stirred and sent inward to remind the inner planets of their origins. It is also a place where anomalies hide. Strange alignments, unexpected inclinations, mysterious orbital clusters. Some scientists believe these patterns point to events we have not yet understood, perhaps ancient collisions with massive intruders, or gravitational disturbances from passing stars. Perhaps even interactions with unseen structures in the galaxy. If you could hover in this realm long enough, you might witness the ancient rhythm of the solar system. Objects drifting like dust in a beam of invisible light. Frozen orbs circling paths carved by forgotten forces. The quiet hum of gravitational tides pulling everything slowly, endlessly, without sound. And as you gaze upward at the flat plane of planets glowing far above you, a profound realization settles in. The solar system is deeper, stranger, and more layered than it appears. Beneath the familiar disk lies a complex underworld, silent, frozen, and filled with secrets. A realm where the oldest stories of our cosmic past wait to be uncovered. One question lingers, heavy in the dark. What ancient forces shaped this hidden underworld, and what might still be moving in its depths, unseen? At the distant edge of the solar system, far beyond the last predictable orbits of the planets, the Kuiper Belt stretches outward like a frozen shoreline. For millions of miles, icy bodies drift through this region. Dwarf planets, shattered fragments, and ancient debris left behind from the birth of the planets. But then, suddenly, inexplicably, it ends. There is no gradual thinning, no slow fading of objects into deeper darkness. Instead, the Kuiper belt simply stops, dropping off like a cliff into unimaginable emptiness. This mysterious boundary is known as the Kuiper Cliff. Imagine drifting outward through the solar system, passing the orbit of Neptune and sinking into the quiet, icy calm of the Kuiper belt. At first, you are surrounded by scattered worlds. Some are small and jagged. Others are smooth spheres reflecting the pale glow of the distant sun. Their orbits weave around one another like silent dancers, never touching, never colliding, each following a gravitational path carved billions of years ago. For a moment, it feels peaceful, an ancient cemetery of frozen relics. But as you journey farther, something feels wrong. The density of objects begins to decline much faster than expected. It is as if you are walking through a forest and suddenly the trees thin out in a single step. Within a relatively narrow region of space, the Kuiper belt drops from thousands of icy bodies to almost none at all. Then, abruptly, the emptiness becomes total. No planets. No comets. No dwarf worlds. Only darkness so profound that even the faint glimmer of dust seems to vanish. This sudden absence is unsettling. Space should not behave this way. Planetary systems, by nature, taper off gradually. Yet the Kuiper belt ends sharply like a blade slicing through the outer solar system. Scientists have debated for decades why this cliff exists, but no answer has yet revealed itself with certainty. One theory suggests that the early solar system was once filled with far more material, ice, dust, and rock stretching well beyond the Kuiper belt's current edge. Over time, interactions with Neptune may have scattered most of this material outward or inward, leaving a clean break at the edge of its gravitational influence. According to this idea, Neptune's migration in the distant past carved the Kuiper cliff like a plow clearing snow. But this explanation raises new questions. Why is the boundary so abrupt? Even with planetary migration, debris should scatter gradually, not vanish instantly. The cliff is too clean, too sharp, too defined to fit comfortably within known models of planetary evolution. Another possibility is far more intriguing. Perhaps a massive, unseen object once orbited beyond Neptune, shepherding material into specific regions and clearing out others. A rogue planet, a super-Earth, or an ice giant that has long since been ejected, or perhaps still lurks far beyond detection. Its gravity could have swept away objects, sculpting the cliff like a cosmic chisel. If such a world existed, its fingerprints might still be hidden in the orbital patterns of distant bodies. Some scientists go even further, proposing that the Kuiper cliff is a sign of something external, something not belonging to the solar system at all. Maybe a passing star thousands of years ago stripped away the outer material. Maybe the solar system drifted through a dense region of interstellar medium that cleared the area. Or perhaps the cliff marks a boundary where the sun's gravitational dominance sharply loses ground to the galactic tide. As you hover at the edge of this desolate region, the feeling of unease deepens. The sun behind you has shrunk to a pale spark, barely illuminating the cold darkness. Ahead lies the emptiness beyond the Kuiper belt, an area so rarely mapped that even our best models are more guesswork than certainty. This emptiness feels intentional, like a doorway leading into a deeper unknown. The cliff also marks a boundary between different eras of cosmic history. Inside the Kuiper belt, objects preserve the conditions of the early solar system. Their chemistry, structure, and orbits reveal stories of formation and migration. But beyond the cliff, those traces vanish. It is as if the record of our system was abruptly torn away. Whatever lies beyond this point does not share the same ancestry. This is the threshold where the solar system begins to lose itself to the galaxy. Here the sun's pull is weaker. Galactic forces grow stronger. The interstellar medium presses inward. And the invisible architecture of the Milky Way begins to tug at objects more forcefully than the sun does. As you drift along the edge, the silence becomes overwhelming. The emptiness beyond the Kuiper cliff feels almost unnatural, as if something has swept through this region and left nothing behind. Perhaps the cliff is the scar of an ancient cosmic event, one we have no record of, no evidence for, except this vast absence. The thought is unsettling. Emptiness can be as meaningful as presence. A missing piece can reveal more than a visible one. And here, at the sharp edge of the Kuiper belt, the solar system exposes one of its deepest puzzles. One that hints at missing worlds, missing histories, and forces we have yet to comprehend. As you stand on the edge of this cosmic precipice, looking into the darkness beyond, one question lingers in your mind. What erased the outer frontier of our solar system, and what is waiting in the silence just past the cliff? In the frozen wilderness far beyond Neptune, where the sun is little more than a dim star and the darkness thickens into a near-eternal night, strange patterns emerge in the orbits of distant worlds. These objects, tiny, icy, and ancient, move in ways that defy expectation. Their orbits cluster together in the same direction, tilt at similar angles, and stretch into elongated paths that all point toward a region of space where nothing visible can be found. It is as if something massive sits out there in the dark, tugging at them gently yet relentlessly. Something heavy enough to bend their orbits, but hidden so well that no telescope has yet revealed its shape. This unseen force has a name whispered through scientific debates and public imagination alike: Planet 9. For decades, astronomers believed that the outer solar system followed a predictable pattern. Neptune's gravity dominated the region, shaping the scattered disk and governing the behavior of trans-Neptunian bodies. But then came discoveries like Sedna 2012 VP113, and other distant objects whose orbits refused to obey the known gravitational architecture. They were too far, too tilted, too aligned, as if tracing an invisible boundary created by an unseen shepherd. Imagine drifting through this outer darkness, following the paths of these strange worlds. They move like whispers, slow, cold, deliberate, arcing through their immense orbits over thousands of years. As you trace their patterns, a larger picture begins to form. The orbits are not random. They point toward a common region, as if pulled by a phantom planet circling far beyond the known frontier. Planet 9, if it exists, would be unlike any world we have ever seen. It would not be a gas giant like Jupiter, nor a rocky world like Earth. It would likely be a super-Earth or mini-Neptune. Something between 2 and 10 times the mass of Earth, cloaked in thick layers of ice and atmosphere. Its faint glow would be too dim to see with ordinary instruments. Its orbit might be so distant that it takes tens of thousands of years to circle the sun once. Out here, in the farthest reaches of the solar system, time moves differently. Seasons last centuries. Darkness dominates almost completely. The sun's warmth is little more than a memory. If you could approach such a world, you might see a landscape of icy storms swirling through an atmosphere illuminated only by starlight. Mountains of frozen gases could rise from the surface. Winds might howl across plains that have never seen sunlight strong enough to cast a shadow. The sky would be pitch black, dotted with cold, distant stars. The sun itself would appear as a bright star, not a glowing disk. This world would be a lonely wanderer, drifting through the outer dark with no moons close enough to warm it, no nearby planets to share its path. But this phantom planet, if real, would not be entirely alone. Its gravity would command a region stretching billions of miles, affecting every object that crosses its domain. It could trap smaller bodies into long resonant orbits. It could tilt the paths of passing comets. It could explain the curious clustering of distant objects that first hinted at its existence. Perhaps it even carved out parts of the Kuiper belt, creating gaps and patterns that seem strangely artificial. Some of these features can't be fully explained by known planets alone. Something unseen is altering the outer architecture of the solar system. Yet no telescope has captured its image. Nothing has revealed its shape or size. It hides in a part of the sky filled with countless faint stars, drifting through regions where our instruments struggle to see. It could be cloaked by dust, positioned in the direction of the bright Milky Way, or located farther away than even the most cautious predictions assume. Some scientists suggest humanity has been looking in the wrong place entirely. Others believe the planet might be temporarily lost in the glare of overlapping star fields. It is a cosmic riddle, and every new discovery deepens the mystery. Some theories go further still, suggesting that Planet 9 may not be a planet in the traditional sense. It could be a captured rogue planet, one that formed around another star and was stolen by the sun during its youth. In the early days of the solar system, when the sun was born in a cluster of stars, close encounters were common. A passing star could have left behind one of its outer planets, and the sun's gravity could have adopted it into a long, looping orbit. If this is true, Planet 9 may not share the same composition as the other planets. It may be an alien world, a visitor from another solar system that now drifts invisibly on the edge of ours. Other possibilities are even stranger. Some theorists have proposed that the mysterious gravitational effects could be caused by something exotic. A tiny black hole left over from the Big Bang, perhaps, orbiting the sun like a pin-sized point of infinite density. Such an object would be nearly impossible to detect directly. It would generate no light, no heat, no reflection. It would be a hidden gravitational ghost, warping the orbits of distant objects while remaining forever unseen. More moderate voices argue that we may be misinterpreting the data, that undiscovered objects in the Kuiper belt could mimic the gravitational effects we attribute to Planet 9, or that galactic tides might play a larger role than expected. But each attempt to explain the evidence without invoking a massive planet only deepens the inconsistencies. The orbits remain too aligned. The inclinations remain too specific. The patterns too coherent. As you drift through the outer darkness, you look back toward the sun's distant glow. The solar system feels fragile, intricate, tightly balanced. Every orbit is a whisper of ancient forces. Every path reveals a chapter of a story billions of years old. And out here, beyond the worlds we know, a silent presence may be guiding the dance, a presence too distant to see, too massive to ignore. The distant objects below you continue their slow, elegant arcs, seemingly pointing like celestial arrows toward something hidden in the cold. You trace their paths, imagining the massive, unseen force pulling gently at their orbits. And a strange sensation settles in. The solar system may not be complete. It may still hold secrets, worlds, or entities we have never glimpsed. At the edge of the known frontier, one question hangs in the silence like a frozen breath. Is the outer darkness shaped by a hidden world, or by something far stranger, waiting silently in the void? As you drift upward from the solar system's plane, leaving behind the braided orbits of the planets and the faint shimmer of distant icy debris, the darkness surrounding you begins to change. It is subtle at first, a faint glimmer, a soft glow filtering through the black. Then, slowly, the void gives way to something grander, something immense and breathtaking. You are rising toward the galactic plane, the vast, glowing heart of the Milky Way that stretches across the sky like a celestial river. From Earth, it appears as a faint, milky band. But from here, above the solar system, it becomes an overwhelming ocean of stars, dust, and ancient light. The galactic plane is not a flat surface but a luminous sheet of concentrated cosmic energy. It is the spine of the galaxy, the place where most of its stars reside, where gas clouds swirl into new suns, and where magnetic fields twist into colossal structures invisible from your place within the solar system. As you ascend toward it, you are struck by the stark contrast between the emptiness below and the dense brilliance above. The solar system, once vast and seemingly infinite, now appears as a tiny outpost drifting beneath a glowing cosmic ceiling. From your new vantage point, the Milky Way stretches horizontally across space like a shimmering continent made of starlight. Countless suns, each with their own planets, their own histories, their own mysteries, are woven together in a glittering tapestry. Dark lanes of dust carve shadows through the light, forming immense silhouettes shaped by gravity and time. These clouds, dense, cold, and ancient, are the birthplaces of stars, where hydrogen collapses under its own weight and ignites into new fire. As you gaze upward, the galactic plane resembles an ocean surface seen from beneath. Waves of brightness ripple across it. Clusters of stars gather like glowing islands. Supernova remnants, vast and colorful, expand through the plane like the ripples left behind by pebbles thrown into water. Everything feels alive, moving, shifting on scales far beyond human comprehension. The solar system's quiet rhythm is nothing compared to the turbulent heartbeat of the galaxy's core. The light here is not gentle. It is fierce, relentless, ancient. Each point of brightness represents a sun blazing in its own part of the galaxy. Some stars are blue-hot giants, radiating incredible energy. Others are yellow or white, steady and enduring. Many are red dwarfs, faint but numerous, forming a silent majority. Beyond them lie rare and violent objects, neutron stars, magnetars, black holes, all hidden somewhere within the galactic glow. The closer you drift toward the plane, the more its influence becomes apparent. Invisible gravitational tides sweep through this region, affecting objects far below it, including the solar system. Over millions of years, these tides subtly shift the orbits of comets, encouraging some to fall inward toward the sun. The galaxy's disk exerts a pull on everything around it, shaping the movement of stars and systems in ways humanity is only beginning to understand. And the solar system does not remain static relative to this cosmic ocean. It oscillates, rising above the galactic plane, then dipping below it like a ship riding slow, immense waves. This vertical motion takes tens of millions of years to complete a single cycle. When the solar system moves through the plane, it encounters regions of higher density. More dust, more gas, more stellar radiation. Some scientists wonder whether these crossings influence Earth's climate, extinction events, or the behavior of comets. Each crossing is a moment of cosmic vulnerability, when the protective bubble around the solar system meets the dense, energetic environment of the galactic disk. From your elevated perspective, the plane looks dense and chaotic, yet stunningly beautiful. Bright star clusters shine like jewels embedded in the disk. Stellar nurseries glow pink and blue with ionized gas. Dark nebulae snake through the light, forming shapes like coiling dragons of dust. The galactic magnetic field stretches across the plane, shaping the formation of stars and guiding charged particles in spiraling paths. These magnetic structures extend far above and below the plane, touching the regions where the solar system drifts. The scale of the plane is overwhelming. It is thousands of light-years thick and extends for tens of thousands of light-years in every direction. Even from your distant vantage point, its immensity dwarfs everything else. The solar system is nothing more than a tiny bubble drifting beneath this cosmic roof, like a dust mote floating beneath a brilliant sky. If you rise even farther above the plane, the galaxy begins to flatten into a familiar spiral, the grand structure we see in textbooks. But from within its depths, the plane is far more complex than any simple diagram could convey. It is a place of creation and destruction, order and chaos, beauty and violence. Supernova explosions carve bubbles in the disk, pushing gas outward. Gravitational waves ripple through the plane, sculpting spiral arms. The density of stars creates a glow that seems to pulse gently, like the breathing of a sleeping titan. As you hover in this luminous region, looking down upon the worlds below, the solar system becomes a fragile, isolated island, floating quietly in the shadow of an immense galactic storm. The contrast is humbling. Beneath you lies a tiny system of planets circling a single star. Above you stretches a colossal, interconnected realm of billions of suns. And one question becomes inescapable: how much of the solar system's past, its formation, its evolution, even the emergence of life, has been shaped by the galactic plane looming above? Far out in the darkness, where the solar system drifts quietly through the galaxy, traces of ancient violence still linger like faint scars etched into space itself. They are not visible to the eye. They do not glow or roar or leave trails of fire. Instead, they hide in particles, in isotopes, in subtle signatures scattered across Earth and the solar system. These are the echoes of supernovae, massive stellar explosions that once erupted dangerously close to our cosmic neighborhood. Their shockwaves may have brushed the edges of the solar system, shaping its past, influencing its climate, and possibly altering the very course of life on Earth. Imagine drifting away from the planets, rising above their orbits until the sun becomes a small beacon behind you. From this vantage point, the galaxy sprawls out in all directions, a colossal spiral filled with brilliant stars. Yet among those stars lie the ghosts of giants that once burned fiercely and died violently. When these massive stars reached the end of their lives, they collapsed into themselves and exploded outward in titanic blasts. Supernovae so bright they could outshine galaxies, so powerful they could reshape space for hundreds of light-years. The solar system, quiet and fragile, was not always far from such devastation. As you drift farther into the void, the silence deepens. But silence is not safety. Hidden in the darkness are remnants of past explosions, expanding shockwaves of radiation and particles that have been traveling for millions of years. Long ago, some of these shockwaves passed close enough to our world to leave fingerprints in the geological record. Layers of Earth's crust contain radioactive isotopes like iron-60, a rare form of iron that can only be produced in supernovae. These isotopes should have decayed long ago if they had originated from Earth or the solar system. Their presence is a cosmic message. At least one supernova exploded near us within the last few million years. Picture that ancient moment. A massive star, perhaps 15 or 20 times the mass of our Sun, reaches the end of its life. Its core collapses, and in a fraction of a second, energy erupts outward with unimaginable force, trillions of times more powerful than the Sun's lifetime output. A brilliant flash sweeps across the galaxy. Radiation plunges through space. Shockwaves push clouds of gas, dust, and atoms outward like a cosmic tsunami. Any nearby star systems that lie too close would be bathed in lethal radiation, their atmospheres stripped away, their planets sterilized. The solar system was lucky. Based on the traces found on Earth, the supernovae that left these isotopes were likely between 100 and 300 light-years away. Close enough to affect our world but not close enough to destroy it. When their shockwaves reached the edge of the heliosphere, they pressed against it like a rising tide hitting a shore. The heliosphere may have shrunk dramatically, exposing the inner planets to increased cosmic radiation for hundreds or thousands of years. Some scientists believe this increase in cosmic radiation may have altered Earth's climate. By ionizing particles in the atmosphere, supernova radiation could have increased cloud formation, cooling the planet. Others speculate that bursts of cosmic rays may have sparked evolutionary pressures, driving species to adapt or perish. The timeline of nearby supernovae coincides intriguingly with certain extinction events and climate shifts. Was this coincidence, or a subtle hand guiding the story of life? Floating through the region where these shockwaves once passed, you imagine the moment they touched the solar system. The sun's protective bubble trembled. Charged particles surged inward like invisible storms. Comets in the Oort cloud were disturbed. Dust was pushed toward the planets. High-energy radiation bathed Earth's surface. It would not have been immediately deadly, but over centuries it could have altered ecosystems, reshaped environmental patterns, and influenced the genetic path of countless organisms. These ancient explosions also contributed something indispensable: heavy elements. The iron in your blood, the calcium in your bones, the gold in jewelry, the uranium deep within Earth's crust. All were created in the hearts of exploding stars. Supernovae scattered these elements through space, where they eventually became part of the molecular cloud that formed the solar system. Without the deaths of long-forgotten stars, Earth, and life, could not exist. The echoes of past supernovae also shaped the very environment the solar system travels through. The region surrounding us, known as the local bubble, is a vast cavity in the interstellar medium. It was carved, it is believed, by multiple supernova explosions over the past 10 to 20 million years. Their shock waves swept the gas and dust away, leaving behind a low-density void, an enormous cosmic crater within which the solar system now drifts. You imagine those explosions occurring one after another, like cosmic artillery shaping the region we now call home. Each blast expanding, merging, sculpting the space around us. The solar system may have entered this bubble long after those explosions faded, passing through a quiet hollow left behind by ancient violence. And this journey continues even now, as the solar system moves through different regions of the galaxy, encountering remnants of distant explosions that occurred long before humans ever existed. But the echoes continue to arrive. Scientists have detected fresh iron-60 in Earth's oceans and the Moon's surface, indicating that material from a relatively recent supernova, within the last few million years, is still drifting through space and settling on planets. These particles are not harmful. They are the faint residue of an event too far away to threaten us. Yet their presence is a reminder: the stars are not quiet. The galaxy is not still. Forces far beyond our control continue shaping our destiny, whether we notice them or not. And what of the future? Somewhere in the galaxy, massive stars are preparing to die. A supernova within a few dozen light-years of Earth could be catastrophic, destroying ozone, flooding the planet with radiation, potentially triggering mass extinction. Fortunately, no such stars appear close enough at present. But the galaxy is vast and the solar system is always moving. Over millions of years, nothing is certain. As you drift through this silent region touched long ago by ancient explosions, you feel the weight of time pressing against you. The echoes of supernovae are not loud or violent anymore. They are quiet, nearly imperceptible, but they carry the memory of cosmic destruction. They are whispers from the dying giants that helped build the universe we inhabit. One final question lingers, cold and haunting. If these stellar ghosts shaped our past, what future supernova lies hidden in the galaxy, waiting silently to reshape our destiny once again? The deeper you drift into the galaxy's vast expanse, the more you begin to sense that the solar system is not wandering through empty space. Instead, it floats inside something enormous, something shaped by ancient explosions, by forces that once tore through this region with unimaginable power. That something is the local bubble, a vast, cavernous void carved into the interstellar medium. It is an enormous cosmic chamber stretching hundreds of light-years across, surrounding the solar system like the hollow interior of a titanic cathedral made not of stone, but of dust-thin gas and faint magnetic echoes. From Earth we cannot see it. Our skies reveal only the dim glow of distant stars. But if you could rise high above the solar system and peer outward with senses attuned to interstellar gas and plasma, you would see it clearly: an immense, irregular cavity glowing faintly at its edges, its walls sculpted by ancient violence. The solar system sits astonishingly close to the center of this bubble, drifting through its low-density interior like a tiny boat floating in a vast underwater cave. The story of the local bubble begins tens of millions of years ago, when massive stars lived and died in this region of the galaxy. These stars were giants, short-lived, unstable, and destined for spectacular ends. One by one they reached the end of their nuclear fuel, collapsed under their own weight, and detonated in colossal supernova explosions. Each explosion unleashed shockwaves powerful enough to sweep the interstellar gas outward, carving vast cavities in the surrounding medium. Over time these shockwaves overlapped, merging into one enormous void, the bubble we now inhabit. Imagine the moment one of those ancient stars exploded. A blazing sphere of light would have burst outward, brighter than entire galaxies for a brief instant. Its shockwave would have raced across space like a cosmic hurricane, pushing the interstellar gas outward, compressing dust into dense shells, and hollowing out the region around it. Multiply that event by a dozen or more supernovae detonating over several million years, and the result is a single, massive structure, the local bubble. Now, millions of years later, the bubble has cooled, expanded, and softened. Its interior is filled with thin, hot plasma, so thin that the vacuum of space inside the heliosphere seems dense in comparison. The Sun, drifting peacefully through this vast cavity, is effectively traveling inside the long-faded memory of cosmic destruction. The edges of the bubble, the walls, are regions where gas and dust were compressed by those ancient shockwaves. Today they glow faintly under the ultraviolet light of nearby stars, forming a ghostly shell surrounding our entire neighborhood. As you drift toward one of these walls, it becomes clear that it is not uniform. Some regions are thicker, denser, glowing with the faint signatures of hydrogen gas. Others are thread-like, almost shredded, torn apart by magnetic turbulence or shaped by additional supernovae over the millennia. These walls are not silent. They are active landscapes of cosmic interaction, places where the pressure of the interstellar medium pushes against the remnants of ancient explosions, where magnetic fields twist into intricate patterns, and where dense clouds of gas begin to collapse under their own weight to form new stars. Indeed, the local bubble is not just a relic, it is a cradle. Its walls are dotted with young stellar nurseries, places where dust and gas have gathered into dense knots. Some stars now shining brightly near our solar system may have been born in these very walls. The Pleiades, for instance, and several nearby OB associations lie in regions influenced by the bubble's structure. The bubble protects, shapes, and guides the evolution of the region around us. As Earth and its neighboring planets orbit the Sun, the entire solar system moves slowly through this giant cavity at tens of thousands of miles per hour. This motion is not isolated, it interacts with the bubble's interior. The heliosphere, the Sun's protective magnetic bubble, expands and contracts depending on the density of the interstellar medium it encounters. In some regions of the local bubble, the gas is thinner, allowing the heliosphere to grow larger. In slightly denser pockets, it shrinks inward, exposing the solar system to more cosmic radiation. This means that Earth's cosmic environment has changed over millions of years as we cross through different regions of the bubble's interior. Some scientists speculate that shifts in cosmic ray levels caused by these movements may have influenced climate cycles, atmospheric chemistry, or even the pace of evolution. But the local bubble is not static. It is expanding slowly. The motion is subtle, driven by residual pressure left over from the ancient explosions that created it. It continues to push outward into the surrounding medium, though the force is now weak compared to what it once was. Still, the bubble grows, its walls moving like the slow breathing of a colossal creature asleep in the deep of space. Behind you, the Sun glows quietly, unaware of the vast structure that surrounds it. Ahead, the bubble's walls stretch like pale ridges across the galaxy. And all around, distant stars illuminate the faint dust that lingers within the cavity. One of the most unsettling realizations emerges as you float within this cosmic hollow. The solar system did not come to the local bubble by coincidence. It may have been shaped by these supernova events. The shockwaves that carved the bubble could have compressed the molecular cloud from which the Sun formed, triggering its birth. If true, then the Sun is a child of this ancient destruction, born not in peaceful isolation but in the turbulent aftermath of stellar death. Even more haunting is the knowledge that the solar system will not remain in the local bubble forever. It is drifting toward the edge. In a few million years, it may enter a denser region of interstellar gas. When that happens, the heliosphere could shrink dramatically. Cosmic radiation levels could rise. Conditions throughout the solar system might change in ways humanity cannot yet predict. For now, though, the Sun sails through this quiet void, safe, sheltered, unknowing. The local bubble is a cathedral of memory, a structure built from the echoes of dead stars. And as you drift within its vast, hollow interior, one thought lingers like a whisper carried on ancient cosmic winds. The past shaped this place, and the future will reshape it again. The solar system is not anchored in place. It does not sit still in the galaxy like a painting hung on an invisible wall. It is a moving vessel, an ancient ship drifting through a vast cosmic sea, carried along by the gravitational currents of the Milky Way. From Earth, the sky appears unchanging, but in reality, everything is moving. The Sun, along with its family of planets, moons, asteroids, comets, and drifting dust, sails through interstellar space at nearly 500,000 miles per hour. And as it travels, it enters new regions of the galaxy, regions filled with different densities of gas, dust, magnetic fields, and radiation. Each region carries potential consequences, silent and unseen. Imagine rising far above the solar system, watching it drift through the void. The planets trail behind the Sun in elegant spirals, wrapping around its forward motion like threads around a spindle. Their paths are not perfect circles. They are helical, corkscrewing through space as the entire system moves together. The result is a dance unlike anything seen in simple diagrams. A symphony of curved motion, a grand procession of worlds following the Sun across the galaxy. As you drift alongside this celestial caravan, a quiet realization settles in. The solar system is like a ship passing through different waters. Sometimes it drifts through calm seas, where interstellar gas is thin and radiation levels are gentle. Other times it crosses turbulent regions, where cosmic rays intensify, magnetic fields twist unpredictably, and dust clouds press against the Sun's protective shield. These environmental changes matter. The solar system's motion affects the shape of the heliosphere, the Sun's magnetic bubble. When traveling through low-density regions, the heliosphere expands, offering better shielding against cosmic radiation. But when entering denser areas, the heliosphere contracts, allowing more high-energy particles to slip inside. Over millions of years, this ebb and flow of cosmic influence may have subtly shaped Earth's climate, life cycles, and even evolutionary pathways. As you watch the Sun's silent voyage, you begin to notice the stellar neighborhoods it passes through. In the past, the solar system may have come frighteningly close to other stars, close enough for their gravity to disturb the distant Oort cloud, sending icy comets plunging inward. Some scientists believe such disturbances may have sparked comet storms or even triggered mass extinctions on Earth. A passing star, even at several light-years away, can alter the architecture of the outer solar system for eons. In the future, the Sun will continue its journey toward new regions of the galaxy. It will eventually pass near dense interstellar clouds, vast rivers of gas and dust stretching across space. These clouds glow faintly under the light of nearby stars. Some are harmless. Others are dense enough to compress the heliosphere to a fraction of its current size. If the solar system enters one, Earth could be bombarded with cosmic rays far more intense than anything seen in recorded history. The effects could range from atmospheric disturbances to increased mutation rates in living organisms. But the solar system's motion is not random. It follows a long, looping orbit around the center of the Milky Way, completing one full revolution roughly every 230 million years. Each journey is a galactic year, a cosmic cycle older than the dinosaurs, older than most species that ever lived on Earth. During each loop, the solar system crosses spiral arms filled with star-forming regions, supernova remnants, and molecular clouds. These crossings expose the planets to different cosmic environments, like a ship traveling from calm tropical waters into storm-tossed northern seas. As you drift along with the solar system, the vastness of its journey becomes overwhelming. The Sun has completed roughly 20 such galactic years since it was born. During that time, it has witnessed the rise and fall of ancient stars, passed through zones of radiation, crossed magnetic boundaries, and sailed through quiet cosmic deserts. And through all of it, Earth's fragile environment has evolved under ever-changing cosmic conditions. The future holds its own mysteries. The solar system is moving toward the Orion Arm, a minor spiral arm filled with glowing nebulae and young, hot stars. Eventually, it will pass near regions where supernova explosions are more common, increasing the potential for cosmic encounters. These events are far in the future, millions of years away, but they remind us of the treacherous nature of interstellar space. The solar system's motion also changes our view of the galaxy. Over millions of years, constellations shift and distort, new stars appear on the horizon, and ancient ones drift away. The night sky seen by Earth's distant descendants will be unrecognizable compared to ours. Even the position of the solar system relative to the galactic plane shifts, altering its exposure to cosmic radiation and interstellar material. Yet through this slow, graceful voyage, the Sun continues to guide its family of worlds with unwavering light. The planets move in their timeless orbits, unaware of the cosmic ocean they are crossing. Earth continues to spin, life continues to grow and evolve, and humanity continues to look outward, trying to understand the forces shaping its existence. As you drift alongside this moving celestial ship, watching the spiraling paths of planets following their luminous captain across the galaxy, one question rises like a whisper from the void. How will the next chapter of this cosmic journey reshape the worlds within the solar system, and the fragile life clinging to one of them? For most of human history, the galaxy seemed like an unmoving backdrop, an eternal canvas of stars. But the deeper we look, the more we discover that the Milky Way is not still. It is alive, breathing in slow cosmic rhythms, shaping everything within it, including the path of our own solar system. And one of its most haunting patterns is the Great Galactic Cycle, a vast oscillation that lifts the solar system above the galactic plane, then pulls it beneath again, in a slow, majestic, and sometimes perilous cosmic dance lasting tens of millions of years. Imagine rising high above the solar system, watching the galaxy spread out like a glowing spiral tapestry below you. The sun is not drifting gently through this grand structure. It is bobbing, rising, and falling like a ship riding waves so immense that they stretch thousands of light years. This motion is not random. It is governed by the gravitational pull of the galaxy's disk, dark matter halo, and spiral arms. The solar system is caught in a vast gravitational tide, moving in a cycle that repeats every 60 to 70 million years. This oscillation is slow but relentless. At one phase of the cycle, the solar system drifts far above the galactic plane, into regions where stellar density thins, radiation weakens, and cosmic dust becomes scarce. At another phase, the solar system plunges back toward the dense central sheet of the galaxy, into a realm filled with gas clouds, magnetic turbulence, heightened radiation, and ancient cosmic debris. As you observe this journey, the first thing you notice is the enormous scale of the movement. Rising above the plane is like ascending toward a shimmering ceiling of stars, watching the Milky Way's central band become narrower and more distant. The light from billions of suns begins to dim. The dust clouds that once obscured our view fade into a faint haze. In these higher regions, the galaxy feels quieter, thinner, almost serene. But serenity is not always safety. Some scientists propose that when the solar system rises above the galactic plane, it may encounter increased cosmic radiation from the intergalactic medium. With fewer dust clouds and fewer stars blocking harmful rays, Earth's atmosphere could be exposed to higher levels of high-energy particles. These particles, striking the atmosphere, may influence everything from cloud formation to mutation rates in living organisms. Then, slowly, the solar system begins its long descent again, falling back toward the galactic plane like a diver sinking toward a luminous ocean floor. From your vantage point above, you watch the Milky Way's central band widen beneath you, growing brighter, denser, and more complicated. Dust lanes thicken into intricate patterns. Star clusters glow more intensely. Nebulae bloom like cosmic flowers. The environment becomes more active, more vibrant, and potentially more dangerous. Crossing the galactic plane is not a gentle transition. It is a plunge through the most crowded and energetic region of the galaxy's disk. Here, the gravitational field is strongest. Stars are packed more densely. Gas clouds swirl in massive currents. Magnetic fields twist into chaotic shapes. This is the heart of the galactic structure, a glowing ocean of energy and matter. As you drift into this region, the environment pulses with radiation. Supernova remnants linger like old wounds in the fabric of space. Molecular clouds stretch like dark curtains. The solar system must pass through this crowded environment, enduring whatever cosmic weather it encounters. Some scientists even speculate that these crossings may correlate with mass extinctions on Earth. Every 60 to 70 million years, extinction spikes appear in the fossil record. Patterns that intriguingly echo the timing of the solar system's oscillation. Is this coincidence or cause? Perhaps as the solar system crosses the dense plane, gravitational forces disturb the Oort cloud, sending more comets inward. Perhaps cosmic radiation intensifies, affecting life in subtle or dramatic ways. Or perhaps ancient supernova remnants lurking in the plane bathe the solar system in temporary waves of ionizing particles. The geological record holds hints but no certainties. As the solar system continues downward, the view from your position above becomes dramatic. The galactic plane glows like a cosmic highway stretching across infinity. Lightning-like magnetic filaments crackle invisibly through the darkness. Clusters of newborn stars flicker like bonfires in the mist. The stars in the plane feel closer, brighter, more intense. This is the region where new stars are born and old stars die. It is a crowded nursery and a graveyard all at once. Eventually, the solar system reaches its lowest point, its deepest descent into the galactic plane. Here, the environment is thick with cosmic activity. The sun's protective heliosphere may shrink under the pressure of surrounding gas, exposing planets to higher levels of galactic radiation. Comets long dormant in distant orbits may wake and begin slow journeys inward. Dust clouds obscure parts of the galaxy. The solar system becomes a traveler passing through dangerous weather, its path shaped by ancient, uncontrollable forces. But after millions of years in this dense realm, the sun begins to rise again. Slowly, steadily, the solar system climbs upward, emerging from the plain. The density of stars decreases. The thick dust fades into faint wisps. Radiation levels begin to settle. Space grows quieter, emptier, calmer. The galaxy's central band narrows again, becoming a luminous ribbon across the sky rather than a dominating horizon. From this higher vantage point, cosmic threats seem more distant, more muted. The solar system drifts in these quieter regions for tens of millions of years, orbiting the Milky Way like a bead sliding along an enormous gravitational wave. But the cycle is not over. It will descend again, and rise, and descend. Over and over for as long as the sun burns. This great galactic cycle is one of the universe's slowest rhythms, but its consequences may be profound. Extinctions, climate shifts, bursts of comet activity, each may whisper the influence of this vast cosmic oscillation. Life on Earth has evolved through dozens of these cycles, each descent and ascent shaping environments in ways we are only beginning to uncover. As you float above the solar system, watching it begin another slow climb through the galaxy's vertical tides, one realization becomes impossible to ignore. Everything in the solar system, every planet, every moon, every living thing, rides this enormous wave together. And the question that lingers, haunting and immense, is this: what awaits us in the next descent, when the solar system once again plunges into the bright, turbulent heart of the galaxy? Far beyond the faintest edges of the sun's influence, past the drifting ice of the Oort cloud and the ghostly reach of the heliosphere, lies a realm so vast and so desolate that even the solar system's emptiness feels crowded by comparison. This is intergalactic space, the region beyond the Milky Way's gravitational embrace, where the universe stretches into near absolute nothingness. It is a place so distant, so cold, so unyieldingly silent that human imagination strains to grasp it. Here, the galaxy itself becomes a lonely island floating in an infinite black sea. Imagine rising far above the Milky Way, watching its spiral arms spin serenely beneath you, like a giant cosmic whirlpool of stars, dust, and dark matter. The bright core glows like a molten heart, wrapped in swirling lanes of starlight. Yet even a galaxy this magnificent has boundaries. The farther you travel upward, the fainter the light becomes. The once brilliant disk shrinks into a delicate, glowing pattern. The dark matter halo fades into invisibility. And eventually, the Milky Way transforms into a distant, shimmering cloud suspended in a universe of unimaginable size. You are now approaching the edge, not of the solar system, not of the galaxy, but of an entire gravitational domain. Here, the influence of the Milky Way grows thin, like the final stretch of a shoreline before the open ocean begins. The stars become sparse. Space grows colder. The cosmic background radiation becomes your only companion, humming faintly as the last trace of the Big Bang's ancient glow. Beyond this boundary lies intergalactic space, a region so empty that a single cubic meter might contain just a handful of atoms. It is a desert of staggering proportions. Yet it is not truly empty. Threads of invisible matter stretch between galaxies like faint, cosmic tendrils. These filaments form the grand structure of the universe, a vast web connecting galaxies across billions of light-years. The solar system, the Milky Way, even the entire local group of galaxies are mere beads strung along one of these invisible threads. As you drift farther from the galaxy's edge, the Milky Way begins to look small, astonishingly small. The spiral arms that once seemed endless now appear delicate, like petals floating in darkness. The galaxy becomes a single speck of light among countless others scattered across the void. Each speck is another island of stars, another realm with its own worlds, its own mysteries, its own civilizations, perhaps. From here, the universe does not feel like a place filled with galaxies. It feels like a place filled with emptiness punctuated by rare islands of light. Between these islands, distances stretch beyond comprehension. The gap between the Milky Way and its nearest neighbor, the Andromeda Galaxy, is 2.5 million light-years, a gulf so vast that even light, the fastest thing in existence, would take longer than the entire span of human history to cross it. And yet, galaxies are not static. They drift. They collide. They merge. The Milky Way is currently moving toward Andromeda in a slow-motion cosmic dance that will end in collision several billion years from now. The two galaxies will merge into a single, larger structure. Perhaps an elliptical galaxy, perhaps something stranger. This future event is written into the fabric of intergalactic space, a promise made by gravity that cannot be undone. But this region holds deeper mysteries still. Some theories suggest that intergalactic space may contain wandering stars, rogue suns flung outward by galactic collisions or gravitational slingshots. Imagine a lone star drifting across this emptiness, carrying with it any planets that once orbited it. These orphaned solar systems, wandering through eternal night, are some of the loneliest objects in the universe. And then there is dark matter, the invisible architecture that binds galaxies together. It forms vast halos around galaxy clusters and filaments that span cosmic distances. In intergalactic space, dark matter dominates completely. You cannot see it, cannot touch it, cannot sense it through ordinary means. But its gravity shapes the universe. It sculpts the cosmic web. It steers galaxies. And it stretches out into intergalactic voids and silent, unseen rivers. If you listen closely, though sound cannot travel here, you feel a kind of cosmic hum. A vibration not of noise but of structure. The universe is organized in ways that defy simple explanation. The cosmic web resembles neurons in a vast brain. Galaxies cluster into walls and knots. Voids stretch between them like empty chambers. Standing here, in the endless gulf between galaxies, you sense the immensity of it all. The solar system is not simply small, it is infinitesimal. And yet, there is beauty in this emptiness. The faint glow of distant galaxies forms a tapestry of lights scattered across the cosmic horizon. Some are spirals like the Milky Way. Others are elliptical giants or irregular clusters shaped by titanic collisions. They shimmer like jewels suspended in nothingness. Their light has traveled for millions, sometimes billions, of years to reach your eyes. You are seeing them not as they are, but as they were before humanity existed. As you gaze across this unbounded ocean, a haunting thought emerges. Everything we know, every planet, every star, every nebula, every black hole, exists inside a universe where even galaxies are temporary drifting structures destined one day to fade. The cosmic expansion accelerates. Distant galaxies slip farther away. One day in the far future only the closest galaxies will remain visible. The rest will disappear beyond the cosmic horizon, their light stretched into oblivion by the expansion of spacetime itself. Intergalactic space is not just a location, it is a revelation. A reminder of how fragile and small the solar system is. How incredibly rare warmth and light are in the universe. How precious a star like the sun truly is. As you drift in this abyss, staring back at the tiny glow of the Milky Way, you feel the weight of distance, the depth of silence, and the overwhelming scale of existence. And one question hangs in the cold. What other mysteries lie hidden in the darkness between galaxies, and will humanity ever reach far enough to find them? You have traveled from the inner worlds of the solar system to the outer dark, from the fragile heliosphere to the interstellar ocean, from the magnetic web of the galaxy to the silent abyss between galactic islands. And now, suspended at the edge of everything humanity has ever known, one final question rises from the darkness. Unavoidable, unsettling, ancient. Are we truly alone in the layers above and below our cosmic home? The universe offers no simple answers. It speaks in mysteries, silent signals, strange shadows, unexplained patterns, and vast stretches of emptiness where anything might drift unseen. Yet the deeper you look into the cosmic structure surrounding the solar system, the more impossible it becomes to believe that humanity stands alone on a single tiny world, surrounded by billions of galaxies with no other consciousness stirring in the dark. As you hover beyond the Milky Way's luminous disk, the galaxy glows beneath you like a living organism. It pulses with energy. It breathes through star formation and supernova death. In its spiral arms, billions of stars burn, each potentially encircled by planets of stone, metal, ice, and gas. Many of those worlds lie in temperate zones, bathed in just the right amount of light to host oceans, atmospheres, and perhaps the chemistry of life. The cosmic probability is overwhelming. Life should exist. Somewhere. Somehow. And yet, silence stretches through space like a cold, suffocating blanket. Looking downward at the solar system, floating inside its delicate bubble of light, you see how layered its environment truly is. Above lies the galactic plane, dense with stars and dust. Beneath lies the underworld of tilted orbits and ancient objects. Behind it stretches the dark matter halo, invisible and omnipresent. Beyond that waits the interstellar medium, drifting like a silent fog. And farther still lie the vast magnetic rivers, the supernova scars, the cosmic voids, and the intergalactic deserts. If life exists elsewhere, it might not resemble anything familiar. It could live in forms we cannot imagine, adapted to chemical environments unlike our own. But even if life is common, intelligent life may be rare. Perhaps intelligence arises only under specific cosmic conditions, conditions that depend on safe orbits, stable climates, protective magnetic fields, and long periods without catastrophic bombardment. From this vantage point, the solar system appears fragile enough that intelligence itself feels like an improbable miracle. And yet, you cannot help wondering whether something watches from the upper layers of the galaxy. The region above the solar system is rich with dust and molecular clouds, birthplaces of stars and potential harbors for young, thriving planetary systems. Civilizations there might be older or younger than ours, hidden within dense nebulae or clustered around faint red dwarfs that shine steadily for trillions of years. Below the solar system, deeper than the ecliptic plane, distant objects drift in silence. Long-period comets plunge inward from the Oort cloud as if carrying messages from the outer dark. These wanderers may have passed near other stars in ancient times, collecting dust, ice, or even microbial life. The solar system is not isolated. It is part of a vast, slow-moving network of drifting objects that could, over billions of years, connect star systems like seeds carried by cosmic winds. As you drift farther from the galaxy, the Milky Way becomes a single soft glow against the void. The silence intensifies. And here the idea of life becomes even stranger. The universe may be teeming with signals, radio whispers, encoded pulses, beams of energy, but distance stretches them into nothing. Light from distant civilizations might be so faint by the time it reaches this region that it becomes indistinguishable from the cosmic background hum. Perhaps the silence we perceive is not real. Perhaps it is only a limitation of our technology, our biology, our brief time as a species. Or perhaps intelligence is its own destroyer. Civilizations may flare to life, expand, then disappear long before their signals reach us. The galaxy may be filled with the ruins of extinct cultures, erased by cosmic catastrophes, environmental collapse, or simply the passage of time. If so, we may be drifting through a universe haunted by ghosts, civilizations long gone, their knowledge and stories dissolved into the cosmic background like fading starlight. But there is another possibility, one that whispers from the quiet edges of interstellar space. Perhaps advanced civilizations live where we cannot detect them. Maybe they dwell above the galactic plane, in regions flooded with harsher radiation but also offering clearer views of the cosmic web. Maybe they hide beneath the plane, in the shadowed corridors where comets and dark matter streams drift unseen. Perhaps they use technologies that do not emit familiar signals. Perhaps they communicate through gravitational waves, manipulating space-time itself in patterns too subtle for us to decode. Perhaps their presence is everywhere, and we are simply not yet capable of recognizing their signatures. As you gaze across intergalactic space, the Milky Way diminishes into a glowing ember. Around it, other galaxies shimmer like distant lanterns suspended in endless darkness. Each one holds billions of stars, millions of worlds, and unknowable possibilities. The scale becomes overwhelming. The silence becomes mythic. And the question becomes heavier: how could life exist only here, on one tiny world orbiting an unremarkable star? Your view shifts again, pulling back toward the solar system. It glimmers like a fragile jewel suspended inside its bubble of solar wind. Earth hangs within it, blue, warm, alive. Everything humanity has ever known exists on that small sphere. Every story, every thought, every dream. Yet the universe dwarfs it so completely that the solar system seems almost imaginary against the vastness behind you. If intelligent life exists elsewhere, it may be watching us as we watch the stars, wondering whether they too are alone. Perhaps they have already reached out. Perhaps their messages wander somewhere in the abyss, too faint or too advanced for us to notice. Or perhaps, like humanity, they whisper into the darkness, hoping someone, anyone, whispers back. As you move through the final layer of cosmic perspective, one truth becomes clear. The universe is far too vast, too ancient, too layered with complexity to assume we are alone. And yet, the silence remains. The unanswered question trembles between hope and fear, wonder and dread. Hovering at the cosmic boundary, you face the final, haunting uncertainty. If intelligence dwells above, beneath, or beyond the solar system, will we ever find it, or will it find us first? The spacecraft drifts now in a place where the sun is no longer a presence but a memory. It hangs behind like a distant ember, faint and delicate, its warmth lost long ago to the endless cold. Outward, the dark stretches without horizon, without boundary. A silence so deep it feels ancient surrounds the vessel, pressing against every surface like the weight of eternity. And within that silence, a question begins to echo, quiet at first, then louder: then so profound it seems to fill the entire void. How far will we go? The solar system has unfolded behind the spacecraft like a story told in chapters of light and shadow. Worlds of fire, worlds of ice, worlds wrapped in storms and cloaked in ancient silence. Each planet offered its own lesson, its own warning, its own invitation. And now, as the journey nears the edge of the sun's dominion, the spacecraft becomes something more than a machine. It becomes a symbol. A vessel carrying the accumulated hope of a species that has always reached beyond itself, always strained against the boundaries of the possible. Far away, Earth circles the sun, a blue whisper in the distance. A fragile, glowing sanctuary suspended in the cosmic dark. For all the worlds that exist around it, none have yet offered the warmth, the breath, the life that Earth holds in delicate balance. It is a reminder that exploration is not born of dissatisfaction, but of curiosity. We do not venture outward because Earth is not enough. We venture because something within us refuses to stay still. The spacecraft continues drifting, passing the orbits of planets that once felt mythical. Neptune fades. Pluto vanishes. The Kuiper belt becomes a scattering of icy fragments swallowed by distance. And ahead lies the vast, silent region where the sun's breath weakens and the interstellar medium waits. An ocean of particles, thin and cold, marking the beginning of everything beyond. Here, time no longer feels human. Hours stretch like days. Days stretch like weeks. Light takes half a day to cross the space between the craft and Earth. Every signal is a message sent into a deep well of time, waiting for an answer that will not return until the world below has rotated, its clouds have moved, its people have lived a fraction more of their lives. Yet in this place, humanity feels closer to itself. For the farther we travel, the clearer it becomes that our greatest strength is not our engines, not our technology, not even our intelligence. It is our longing. The deep, collective yearning to know what lies beyond the next horizon. It is the same longing that once pushed us across oceans, across mountains, across skies. Now it pushes us across worlds. The spacecraft hums softly, its system steady. It carries no voice, yet it speaks. Every piece of data it sends back is a message. A reminder that distance is not a barrier, only a challenge. Humanity listens. Scientists watch glowing screens in quiet rooms. Children see images of distant worlds on tablets and whisper stories to themselves about visiting them someday. Pilots imagine steering ships through the rings of Saturn. Engineers design engines that might one day erase the boundaries of the solar system. The question grows louder: how far will we go? The answer is not only found in the machines we build, but in the choices we make. Will we decide to return to the moon in permanent settlement? Will we walk on Mars not as visitors but as residents? Will we send explorers to Europa to search beneath its frozen surface for hidden oceans? Will we glide through Titan's orange sky in aircraft crafted for alien weather? Will we dare to send human beings to the ice giants, to stand near their moons, to witness Neptune's sapphire storms with their own eyes? Some futures imagine humanity spreading through the solar system like seeds carried on a cosmic wind. Domes on Mars glowing at night, cities floating in Venus's upper clouds, mining stations orbiting asteroids, laboratories under Europa's crust. Other futures see humanity building great starships, massive vessels that could one day break free from the sun's gravity entirely. Imagine drifting outward through the cosmos until every galaxy fades into a faint shimmer. The entire observable universe shrinks to a single glowing sphere suspended in an endless void. From this perspective, the truth becomes clear. What we call an ending is only a shift, a transformation waiting to happen. The universe is still writing itself, still unfolding, still evolving far beyond our imagination. Scientists once believed the universe would follow a single path toward its fate. Now, the possibilities branch like cosmic rivers. One future imagines an endless expansion, galaxies drifting apart until their light can never reach each other. Stars burn out. Black holes evaporate. Space grows colder and quieter, yet even in this darkness, new universes might bud from quantum seeds. Creation does not stop, it simply moves to new ground. Another possibility imagines the universe slowing, reversing course, and collapsing inward. Galaxies fall together. Matter compresses. Temperatures rise. The cosmos tightens into an ultra-dense state, not a death but a transition point, before rebounding into a new expansion. In this view, universes are born and reborn in eternal cycles, each one inheriting the echoes of the one before. Or perhaps the future will be stranger still. Expansion accelerating until spacetime itself tears, only for isolated pockets of stability to ignite new realities. Even destruction becomes creation. In every version, one idea remains. The universe does not truly end. It changes form. It evolves. It becomes something new. And in this vast future, consciousness, whether human or something beyond us, may continue the search. The universe may not grant final answers, but it offers an endless horizon of discovery. In a cosmos without a first page, there can be no final one. The story continues and we remain part of its unfolding.